Hello, everyone. This is a video response to a question I had in Thermochemistry Unit 3, Lesson number 1, specifically where we get into nuclear reactions here and how to balance those. The question comes from the Check Your Understanding and question number 4. And so I'm going to go to answer that right now. You can feel free to skip ahead as my daughter interrupts us with some 5-year-old problems. But the solution, I'm going to whiteboard it now, and hopefully that is helpful. So let's switch over to the whiteboard. Okay, so the first thing I will note is that this is a poorly written question. And when you look at the answer, you'll realize that they don't provide you enough information to solve the problem. So let's start off with what we know. Uranium-235. And the first piece of information, which is not explained well in the content or in the question, is that when we have a fission reaction, we are going to have a neutron bombardment. So we are having a neutron react with the uranium nucleus. So that's what a nuclear fission reaction typically looks like, but that really should be explicitly stated. Hi. I'm just coming up to say hello. Well, Sadie?
Lily, I think it's some sort of cream. I was downstairs. Lily was pretending to spray me, and I didn't like it.
Did you tell her that?
No, because she kept saying spray, spray, spray.
Lillian? Lillian?
Yes.
Can you not bother Sadie like that, please? Thank you. Thank you for explaining that to. Thank you, Sadie, for explaining that. Now, the product here we know is going to be cesium-138, but the real problem comes in the other products. So we know that some number of neutrons are going to be produced. Okay, that's explained in the content that neutrons are products of fission reactions. That's how a fission reaction works. The problem comes in not with what the other product is, but with the mass of the other product and the number of neutrons. So let's just complete the atomic number because we can do that. Atomic number has to be conserved. So 92 on the left-hand side, we have 55. So the atomic number has to add up. We have to conserve the atomic number. So the product here, we're going to have rubidium. 37 plus 55 is 92. Now, the mass number up here, on the left-hand side, we have 236. And on the right-hand side, we have 139. And so we have to make up the difference in terms of what the mass number will be for rubidium and how many neutrons. So that's a problem because the answer says 2 neutrons. So that gives us now 140 on this side. And then if I subtract 140 from 236, so I'm subtracting the mass numbers to get the difference, we get 96. Okay, so there's where the answer comes from, but the problem is there's no information about how many neutrons, so that should have been provided. So let me do an example of another question which gives you enough information, and I'll show you how I would solve it. Here's a question that I think provides more complete information, very similar question, and let's solve it together. So it says, write a balanced equation for a fission reaction. So that tells me a heavier nucleus is going to be split apart into 2 or more lighter nuclei caused by neutron bombardment. So when you see the word bombardment, that tells you that that particle is one of the reactants. And then I give you some of the products, but we'll see that those are not complete. Okay, so first of all, we have a fission reaction with U-235, okay, uranium caused by neutron bombardment. Okay, we'll always assume that only one neutron is involved. And then it says we've got 3 neutrons and a PR-147 nucleus. And then we'll just go on the periodic table and remind ourselves that that is element number 59. So if we compare the atomic numbers and mass numbers, we see that they're not balanced. So we know that there's going to be another nuclei. And this is typical of fission reactions. 2 or more nuclei on the product side, and then some particles that are split off as well, typically neutrons. So on the left-hand side, we have 92. On the right-hand side, for atomic numbers, we have 59. So those need to be balanced, or conserved is another way of saying that. So here we would have element number 33. Go to the periodic table, and we see that is arsenic. And then we also need to conserve the mass numbers. So 235 plus 1, 236 is my left-hand side. On the product side, we have 147, and then we have 3 neutrons. So that'll add up in total to 150. And then we go, what's that? 8 and 86. So there's a completed nuclear equation. So note that a little more information had to be provided, specifically the number of neutrons that are released as part of this bombardment there, and just some more information in the question. So if you're stuck by that question that was asked in the notes, that is to be expected. If you have any more questions about anything in the thermal chemistry unit, just shoot me an email and I can respond with a quick video tutorial.